Over 100 billion flowers are harvested each year, enough to submerge the entire city of New York beneath a vivid floral carpet as tall as a 20-story building. With its enormous trading value, the fresh flower industry has officially secured its place among the world's most valuable agricultural commodities, far surpassing export giants such as tea or coffee. It has even set a staggering profit record. Each hectare of cultivation generates revenue up to 20 times higher than that of conventional cereal crops. So how do farmers around the globe manage to beat time, delivering millions of tons of these delicate flowers to consumers before they fade away? In this video, join Agriculture Insight as we uncover the secrets behind the most beautiful industry on the planet, where flowers are treated like luxury cargo, given priority access to air routes, and priced as rapidly as stocks at massive auction markets. Now let's begin. Every year, the Fayoum Valley, the chamomile capital of Egypt, harvests tens of thousands of tons of chamomile flowers to serve the global pharmaceutical and herbal tea industries. To keep pace with the rapidly growing demand, specialized chamomile harvesting machines are the decisive key. The entire process truly begins only after 8 a.m., when the morning dew has completely evaporated, allowing the flower heads to remain dry, preventing clumping and minimizing the loss of active compounds during collection. Chamomile harvesters operate using a unique brushing suction mechanism. A system of steel comb teeth, adjusted to a height of over 25 centimeters, gently brushes along the tops of the plants to separate only the essential oil-rich flower heads, while preserving the stems and leaves below for subsequent blooming cycles. The brushing force is precisely calibrated so that the flower heads detach without crushing their structure and are immediately drawn by a high-pressure airflow into the collection chamber to avoid direct sunlight exposure. With this mechanism, each machine unit can achieve productivity up to 30 times higher than manual labor, filling containers with a load capacity of 3.5 tons within a short period of time. However, the real race against time begins the moment the flowers leave their living sap flow. Because the stamens oxidize very quickly, the entire harvest must be transported urgently to the drying facility within a maximum of 4 hours. There, the flowers are dried using cool, dry airflow rather than high heat to remove 80% of the moisture while preserving their bright yellow color and the valuable active compound apigenin. Only after reaching a stable level of dryness is chamomile transported to the factory for screening and grading, before being exported directly to demanding markets such as the EU and the United States, where it is recognized as a functional medicinal herb rather than simply a relaxing tea. A symbol of the sun, with its radiant golden hue, the sunflower has long been regarded as the flower of light. Yet its true value does not lie in that brilliant beauty, but deep within its massive flower heads, weighing up to 2 kilograms, where thousands of oil-rich seeds concentrate the energy of an entire summer. To fully preserve the essential oil content inside, the industrial harvesting process is only allowed to begin once the plant has completely closed its life cycle. By then, the glorious yellow fades, giving way to vast dark brown fields stretching to the horizon. Leaves wither and droop, petals fall away, and it is precisely in that moment of decline that economic value begins to rise. When the back of the flower head becomes completely dry and seed moisture drops below the 10% threshold, combined harvesters move in simultaneously, sweeping across thousands of hectares of fertile black soil with specialized cutting headers. Unlike rice harvesting, the machines trim precisely the dried flower heads instead of cutting close to the base. At the front, an extended guiding tray system keeps each head upright before it reaches the cutting mechanism, almost entirely eliminating seed loss caused by mechanical vibration. Inside the machine, the impact rollers are precisely calibrated to separate the seeds from the flower head without damaging their structure, achieving a productivity of 30 to 50 tons per day. The remaining stalks and flower residues are chopped and blown back onto the field, forming a natural organic layer that returns nutrients directly to the soil, creating an almost closed-loop cycle. Thanks to such efficiency and precise engineering, on the famed Chernozem black soils of Ukraine, sunflower cultivation has risen into an economic engine worth more than 20 billion USDs each year. Not only does sunflower oil offer an ideal smoke point for cooking, it is also exceptionally rich in vitamin E, a factor that keeps its commercial value consistently twice that of soybean oil, securing a premium position over palm and rapeseed oil in the global market. At the peak of the tulip craze in the 17th century, it was once said that a single rare tulip bulb could be exchanged for a luxurious mansion along the canals of Amsterdam. That tulip mania has gone down in history as one of the first financial bubbles of mankind. And today, the Netherlands has not only mastered that haunting legacy, but transformed it into an agricultural industry with export values reaching up to 2.5 billion USD per year. As the world's leading supplier of tulip bulbs, Dutch farmers operate an almost perfectly standardized cultivation process, in which flower harvesting and bulb harvesting are completely separated to optimize quality. The first stage takes place in mid-spring, from April to May. As soon as the tulip fields reach their most vibrant bloom, specialized topper machines begin appearing in dense formation across the endless carpets of flowers. At first glance, their task may seem ruthless, cutting off the entire blossom at peak beauty. Yet this is precisely the strategic step that generates enormous economic value for the Dutch tulip industry. Although it takes 5 to 7 years for a plant to bloom for the first time, removing the flower is mandatory to halt seed formation. When sexual reproduction is prevented, all nutrients generated through photosynthesis are no longer expended on the petals, but are instead redirected downward to nourish and enlarge the bulb beneath the soil. These topper machines are engineered with high-speed rotating shafts combined with flexible rubber paddles, snapping off the flower heads precisely without damaging the foliage. A height-sensing system adjusts the cutting mechanism along each row, ensuring the leaves, the plant's primary photosynthetic engine, continue operating at maximum capacity. Capable of processing hundreds of hectares per hour, they create a striking display of mechanization across the vibrant fields. By summer, when the foliage has completely withered and all energy has been fully stored beneath the soil, the bulb harvest truly begins. Bulb lifting machines, designed similarly to high-capacity potato harvesters, raise the entire soil layer at a depth of about 20 centimeters. Through a lifting blade mechanism, combined with a layered vibrating conveyor system, the soil is screened directly in the field, and the bulbs are separated cleanly from impurities at a productivity rate of approximately 10 to 15 tons per hour. Many modern systems also integrate low-pressure water cleaning and automatic size grading directly on the processing line. The result is bulbs that reach the standard size of 10 to 12 centimeters, uniform in form, density, and growth quality, ready for replanting in the world's most demanding markets. Notably, the entire bulb management system in the Netherlands has now been fully digitized. Each plot of land is assigned a unique identification code, enabling precise traceability down to every square meter of cultivated area. When mentioning France, many immediately think of the wine industry. Yet across the vast lavender plateaus stretching over thousands of hectares, a fragrance industry operates on a comparable scale, generating up to 2.5 billion USD each year for the global economy. With annual production reaching tens of thousands of tons of fresh lavender, manual harvesting has long ceased to be an optimal option for France's essential oil and fragrance industry. Mechanization has therefore become an inevitable step, ensuring speed, uniformity, and the capacity to meet global supply contracts. On lavender fields in late June, when approximately 80% of the flowers are in bloom and essential oil content in the glandular tissues reaches its peak, cut and collect harvesters are deployed with a capacity of 2 to 4 tons of fresh flowers per hour. Featuring high-speed rotating circular disc blades combined with a hydraulic height adjustment system, the machines are able to cut the flowering stems precisely at a height of 20 to 30 centimeters above the ground. Immediately after being cut, the harvested material is lifted by a conveyor system combined with a gentle suction fan and transferred directly into the storage container, preserving the flower structure, minimizing tissue damage, and allowing distillation facilities to closely control the quality of each batch of raw material. In contrast, the cut-chop direct loading harvester uses a long clamping cutter bar spanning 3 to 4 meters in width to cleanly cut the flowering stems in a single pass, then immediately chops and feeds the material into the storage tank. With a capacity of 6 to 8 tons per hour, nearly double that of the cut and collect system, it enables faster and more uniform distillation, though the flower structure is no longer preserved and the material is specifically suited for large-scale essential oil production. From that moment, the race against time begins. The lavender must reach the distillery the same day to prevent oxidation. After wilting for 12 to 24 hours to reduce moisture, low-pressure steam extracts the aromatic compounds, which are then cooled and separated into essential oil and hydrosol. The Queen of Flowers, with roughly 150 roses cut and sold every second worldwide, serving markets ranging from premium fresh-cut flowers to the multi-billion-dollar perfume industry. If the highlands of Ecuador are known for their near-vertical sunlight year-round, producing rose stems up to 1.5 meters long for European and North American markets, then in Azerbaijan, Rosa damascena is cultivated for an entirely different purpose: essential oil extraction, the most valuable component of this flower. For Rosa damascena, harvest timing can determine up to 60 to 70% of the essential oil quality. The golden hours begin before sunrise, typically between 4 a.m. and 7 a.m., when temperatures range from 12 to 18 degrees and humidity remains high. These cool, moist conditions help preserve the essential oil glands beneath the calyx at peak concentration, particularly citronellol and geraniol, the key compounds responsible for the characteristic aroma of rose oil. This means farmers have only about 3 golden hours to complete the harvest. As soon as the sun rises higher, natural evaporation accelerates, aromatic molecules begin to dissipate, and the economic value of each flower declines by the minute. For a crop with an extremely low essential oil yield like roses, even minor losses can result in significant differences in final output. Beyond timing, the harvesting technique itself requires precision. Each flower must be gently picked by hand, keeping the calyx intact, the part where essential oil glands are most concentrated. If the stem is broken too deeply, or the petals are bruised, the oil glands may rupture prematurely, leading to oxidation before distillation. As soon as they are picked, the flowers are placed into breathable burlap sacks or woven baskets. This seemingly simple choice plays a crucial role, allowing the petals to dissipate heat quickly, preventing moisture buildup, and reducing the risk of natural fermentation, a process that can alter the chemical composition within just a few hours under high temperatures. All harvested roses are then collected and transported to the distillery within a maximum of 2 to 4 hours. To address the rapid volatility of rose compounds, whose aromatic molecules are highly sensitive to heat and light, many distillation facilities are strategically built close to major growing areas. At the distillery, the flowers are unloaded in batches and fed directly into copper stills, a material chosen for its stable heat conductivity and minimal reactivity with aromatic compounds. Low-pressure steam is passed through the mass of fresh petals, rupturing the tiny oil glands within the calyx and carrying the aromatic molecules into a cooling system. Once condensed, the mixture naturally separates into layers. The pure essential oil, being lighter, rises to the top, while rose hydrosol settles beneath. The price of this purity is extraordinarily high. Nearly 3.5 to 4 tons of fresh roses are required to produce just 1 kilogram of Rosa Damascena essential oil. On the international market, this oil can range from 8,000 to 12,000 USD per kilogram, many times more expensive than lavender oil and significantly higher than most citrus oils by weight. Meanwhile, rose hydrosol, the byproduct of distillation, is far less costly, but remains widely used in cosmetics, food products, and herbal applications. And now, let's move straight to the cattle farms of France and Ireland, the epicenter of today's fiercest disputes, yet also one of the greatest sources of pride for the old continent. Unlike the vast million-hectare ranches found in places like Australia or the United States, cattle farming in Europe has never been a game of sheer scale. Although Europe's total herd accounts for less than 10% of the global cattle population, the region still delivers over 12% of the world's premium quality beef. At the core of this system lies a philosophy that seems almost contradictory: working with nature, yet exercising absolute control through technology. Across Europe's fertile temperate grasslands, iconic breeds such as Charolais, with their distinctive white coats, and the muscular Limousin, renowned for their ability to convert grass into lean meat, are allowed to graze freely for at least 8 months each year, maximizing natural forage drawn directly from the land. When winter arrives, the herds are moved into smart livestock barns, where they rest on straw bedding layers up to half a meter thick. This bedding system not only keeps the floors dry, warm, and nearly odor-free, but also significantly reduces animal stress, even when temperatures drop to -10 Celsius. European beef production enforces a strict zero-tolerance policy toward growth hormones and genetically modified feed additives, tools commonly used in the United States to shorten production cycles and maximize industrial efficiency. Instead, supplemental feed consists solely of locally sourced barley and silage corn, ensuring that every cut of beef carrying the European Union label meets consistent standards of structure, marbling, and natural flavor. Beyond that, cattle transport is tightly restricted, capped at 8 hours or 600 kilometers, to prevent stress and panic. Because even a few minutes of acute stress can alter muscle pH levels, instantly downgrading what would have been premium-grade beef into a second-tier product, indistinguishable from meat produced by virtually any standard operation. It is precisely this level of meticulous control that has turned European beef into a luxury benchmark, pushing its export value more than 1/3 higher than that of competing producers in demanding markets such as Japan and across the Arab world. In fact, this standard can be tested directly through steak tartare, France's iconic dish of finely chopped raw beef. Only cuts with stable pH levels, zero growth hormones, and exceptional freshness qualify to be served raw, without any heat treatment, a level of safety and consistency that reflects the extreme discipline behind Europe's beef production system. Accounting for more than 20% of global cheese production, Europe's dominant model is not mega-industrial farms, but mid-sized family operations, typically raising 50 to 300 cows. The 3 productivity leaders are Germany, France, and Netherlands. As labor costs have surged, reaching up to €35 per hour, the industry has undergone a quiet revolution, replacing manual labor with fully integrated automation. Autonomous, feed-pushing robots, repeatedly patrol barn corridors, mixing and delivering hay and silage up to 8 times daily, encouraging cows to move, eat, and maintain healthy circulation. At the same time, overhead automated bedding systems distribute fresh straw, keeping barn floors dry and thermally stable, conditions often compared to a luxury hotel environment. To eliminate heat stress, farmers deploy networks of high-capacity fans that deliver fresh airflow directly to each resting stall. Adjustable nozzles generate air speeds exceeding 3 meters per second, cooling the shoulder and chest areas while expelling harmful ammonia gases. Supported by this meticulously engineered environment, from automatic scratching brushes to stress-free housing, each high-yield dairy cow can produce up to 11,000 liters of milk per year. Once collected by robotic milking systems, fresh milk is transferred directly to industrial processors such as Lactalis, Nestlé, and Danone for advanced processing. This hormone-free milk stream forms the foundation of more than 3,500 distinct European cheeses, from Parmesan wheels used as bank collateral in Italy to the soft, creamy brie that defines French gastronomy. No less formidable than its dairy sector, Europe's vast baking tradition, encompassing over 3,200 types of bread and tens of thousands of artisanal bakeries, has turned the continent into the largest bakery on the planet. In France, the undisputed capital of pastry, a traditional baguette is legally permitted to contain only 4 ingredients: flour, water, salt, and yeast. To satisfy this immense demand for grain, July marks the peak of Europe's wheat harvest, when summer heat naturally reduces kernel moisture to the ideal 14% threshold. At this moment, the continent enters an overwhelming campaign of mechanization. Vast wheat fields stretching across hundreds of hectares are overtaken by mega combine harvesters equipped with cutting headers exceeding 12 meters in width. Thousands of cuts per minute pull wheat heads into the threshing chamber, where high-speed rotating drums use intense centrifugal force to separate grain before funneling it into onboard storage tanks. These machines operate like mobile data centers. Infrared sensor systems continuously scan the harvest, analyzing protein content and gluten levels in real time. Wheat batches exceeding 13% protein are routed toward bread production to achieve the desired chew and structure, while lower protein grain is directed to pastry and confectionery lines that require finer, more delicate textures. Thanks to this precision-driven system, wheat yields across the European Union reach record levels of 8 to 10 tons per hectare. Yet the value chain does not end with premium bread. The remaining wheat stalks are compressed into dense straw bales and returned to farms as bedding for beef and dairy cattle, completing a circular agricultural economy in which virtually nothing drawn from the land is wasted. While crops like tomatoes, bell peppers, and cucumbers can see prices triple whenever greenhouse heating gas costs spike, cabbage stands out as one of the few European crops that maintains long-term price stability, thanks to open field cultivation and exceptional tolerance to cold and temperature swings. In northern agricultural hubs such as Germany and Poland, white cabbage is grown for up to 180 days, allowing it to accumulate natural sugars and develop massive heads weighing up to 5 kilograms, specifically suited for fermentation industries. Manual labor has largely disappeared. Today, rotary disc harvesters equipped with vision sensors lift and sever each head with precision in under 1 second. This step is critical. It preserves the cabbage's natural wax layer, a prerequisite for long-term cold storage, enabling the crop to overwinter in climate-controlled warehouses for up to 10 months while retaining near-harvest crispness. For red cabbage, a closely related variety priced up to 30% higher due to strong demand from the fresh salad market, European farmers apply a more nuanced harvesting strategy. Although the same conveyor-based gripping principle is used, red cabbage harvesters are fitted with softer rubber buffers and reduced belt speeds. This configuration prevents skin damage and cellular pigment bleeding, which would otherwise compromise commercial value. A single machine can process up to 50 tons per day, sufficient to meet the continent's massive demand. However, for produce destined directly for supermarket shelves, Europe favors a different approach: semi-mechanized harvesting. Here, workers operate alongside conveyor systems and tractors, manually selecting and cutting only grade A heads. At the field edge, cabbages meeting strict standards for shape and color are placed directly onto packing conveyors, while the remainder is diverted to processing channels. Although Europe cannot rival China's sheer production volume, its ability to minimize damage rates and extend freshness for up to 10 months allows European farmers to consistently command premium prices and avoid the chronic oversupply crises that plague less controlled agricultural systems. You may not know this, but green peas do not actually come from the Netherlands. Although the name traces back to the era when Dutch traders dominated global commerce, in modern Europe, it is France that stands as the true stronghold of pea production, with output 10 times higher than its neighbor, supplying over 2 million tons per year to global markets. Unlike cereal crops that can be left to dry in the field, peas have an extremely narrow harvest window, typically lasting just 12 to 24 hours to achieve grade A sweetness. To meet this challenge, European farmers deploy massive pea viner machines, operating like mobile shelling factories. Gripping mechanisms pull entire pea plants into rotating threshing drums that separate the peas on the spot, while the remaining plant matter is shredded and returned to the soil, recycling natural nitrogen stored in the roots nodules. Immediately after shelling, the peas must be transported to IQF, individually quick frozen facilities, within a critical 2-hour golden window, locking in vitamin C content and natural sugars before degradation can begin. Notably, as the global market moves away from genetically modified soybeans, processing plants in France and Belgium have rapidly repositioned peas as a leading source of clean protein. Beyond frozen vegetables, peas are refined into high-purity protein isolates, forming the backbone of the rapidly expanding plant-based meat and dairy alternatives industry. Thanks to their non-allergenic profile and strong alignment with green sustainability standards, these pea-based products now dominate the premium segment, commanding export values up to 30% higher than comparable pea products from North America. Every single second, 100 meals made from Norwegian salmon are served somewhere around the world. With annual revenues exceeding 11 billion euros, this fish is no longer a wild delicacy. It has become a strategic economic empire, enabling Europe to dominate global dining tables. Behind this immense output, Norway operates giant offshore cage systems built from ultra-durable polymer materials, reaching depths of up to 50 meters, the equivalent of a 15-story building submerged in the open sea. Once juvenile salmon reach the required size, they are transferred into these cages to begin an approximately 22-month ocean growing phase. The open net design allows Arctic Ocean currents to flow freely through the cages, delivering abundant fresh oxygen while naturally flushing away waste, keeping the environment in a near pristine state. Crucially, Norway enforces a golden density rule. Fish may occupy no more than 2.5% of the cage volume, leaving the rest as open water. The constant need to swim against strong currents forces the salmon to burn excess fat, producing firm flesh and distinctive marbled fat patterns, qualities that low-cost industrial farmed fish can never replicate. When the salmon reach a weight of around 5 kilograms, they are not hauled up by nets, as in traditional fishing. Any sudden impact or panic can trigger physiological stress, altering muscle pH levels and directly compromising fillet quality. Instead, the fish are gently guided into wellboats using low-pressure water suction systems, keeping them calm and stable before processing. This strict stress control allows muscle pH to remain within the optimal range, a critical requirement for sushi-grade salmon, safe and stable enough to be consumed raw immediately after processing. From this point, it takes less than 48 hours for a salmon to travel from a Norwegian fjord to high-end restaurants in New York or Tokyo. Inside the processing plant, fully automated systems take over. X-ray scanners analyze bone density to eliminate substandard specimens, followed by high-pressure water jet blades that perform filleting cuts with millimeter-level precision without damaging the cellular structure of the flesh. Today, Norwegian salmon not only dominates menus from sushi and sashimi to pan-seared steaks, but also serves as a premium raw material for high-grade omega-3 extraction. While the European Union remains the largest market, the United States is rapidly emerging as the leading importer outside the region, a clear testament to the global appeal of Nordic green aquaculture at its finest. Advancing across the navy bean fields is one of the most advanced dry bean harvesters in use today. With a closed-loop cut-thresh separate system operating in a single pass, it cuts harvest time nearly in half and boosts productivity to up to 5 tons per hour, a level manual labor could never achieve. Meanwhile, some farms in North America still rely on swathing and windrowing, cutting plants when pods are about 80% dry, laying them in rows to cure naturally for 1 to 2 days before the combine moves in. This method helps stabilize moisture and reduce losses. The name Navy bean traces back to its role as a staple food on U.S. Navy ships in the early 19th century. Today, although less globally common than mung or black beans, navy beans remain vital in states like North Dakota and Minnesota, producing hundreds of thousands of tons annually. Recognized as a natural superfood and contributing significantly to U.S. agricultural exports. In California and Arizona, the largest leafy vegetable production hubs in the United States, broccoli harvesting has become significantly more efficient thanks to conveyor-assisted systems, boosting productivity by up to 30% compared with traditional manual methods. With a swift cut to remove the stem, each head of cauliflower is placed directly onto a mobile conveyor running alongside the workers. Instead of carrying loads by hand or piling them on the ground, the conveyor continuously transports the produce toward the rear, where large bins on a truck await. Workers on the truck simply sort and pack the heads, creating a seamless workflow of cutting, placing, conveying, and packaging, minimizing unnecessary movements and maintaining a steady working rhythm. The blooming flowers gliding smoothly across the fields are part of a cup conveyor system. Each plastic cup supports an individual head of white cauliflower or large broccoli, keeping it stable and protected from bumps or scratches, ensuring optimal quality for storage and export. Thanks to these systems, the United States harvests nearly 2 million tons of broccoli and cauliflower each year, achieving consistent freshness, low post-harvest loss, and far greater efficiency, meeting the growing demand both domestically and in export markets. The shaking-type almond harvester is the backbone of California's vast orchards, the almond capital of the world. Fast, powerful, and remarkably stable, the machine delivers over 1 ton of almonds per hour by clamping the tree trunk with a hydraulic arm and sending high-intensity vibrations through it, shaking the nuts down in seconds without damaging the bark or root system. All fallen almonds are then gathered by a sweeper and transferred to a pickup machine for cleaning and sorting, forming a fully streamlined harvest chain. Most of the state's production still relies on shaking machines, but the breast has become the proving ground for next-generation harvesters. A massive U-shaped design allows these machines to pass through rows, wrap around entire trees, and catch every falling nut with an integrated conveyor system, cutting losses by about 25% compared to traditional shaking. However, their need for flat ground and perfectly aligned rows keeps them from replacing shakers across the state. Thanks to deep, continuous mechanization, California produces more than 1.3 million tons of almonds each year, maintaining its position as the world's leading almond powerhouse for decades. In October, as the chilly fields of the American South glow a deep, fiery red, harvest season reaches its peak. Massive 300 horsepower Case IH tractors pull behind them the towering Pickrite harvesters. Razor-sharp blades slice each row cleanly from the soil, sweeping ripe red peppers onto vibrating conveyors that shake off dirt and leaves before carrying them straight into bulk bins. Within minutes, tons of peppers are loaded and ready for their journey to processing plants, where they will become the sauces, powders, and signature spices of Latin American cuisine. Yet amid the relentless rhythm of mechanization, some peppers are still handled with pure craftsmanship. Tabasco, a 150-year icon of American flavor, remains one of the few brands committed to hand-picking. Every year, the company produces more than 70 million bottles of hot sauce, all beginning with tiny peppers plucked by hand on Avery Island. It is a living reminder that precision and tradition can still stand firm in an age ruled by machines. These Ploger pea viners are the true heavyweights of the industrial pea harvesting world. Standing over 4 meters tall and nearly 12 meters long, they operate like mobile processing plants across the field. In just 1 hour, a single machine can sweep through almost 10 hectares and collect dozens of tons of fresh peas, an output hundreds of manual workers could barely match. Yet the Ploger's real superiority lies not only in power, but in mechanical precision. A low-cut header lifts the vines without crushing the pods before a spiral conveyor feeds the plants into the threshing chamber. Inside, the rotor and vibrating screens work in perfect sync, strong enough to separate the peas, gentle enough to preserve their firmness and natural sheen. Airflow systems then strip away leaves and stems, while clean peas fill the rear hopper and are offloaded directly into a truck moving alongside, keeping the entire operation continuous and uninterrupted. Thanks to these harvesting giants, the Netherlands leads Europe in industrial pea production, accounting for over 30% of the region's output and reinforcing its status as one of the world's most advanced agricultural powerhouses. San Joaquin Valley, California, the largest grape-growing region in the United States, is known for its DOV, the rye, dry-on-vine raisin production, a technique that allows grapes to dry directly on the trellis instead of being laid on the ground. This is the defining advantage of DOV, something the traditional tray drying system cannot offer. Each year, the region produces hundreds of thousands of tons of raisins using this method, cutting labor costs dramatically and reducing weather-related risks that often threaten sun-drying. Instead of harvesting fresh clusters, growers perform cane cutting once the grapes reach peak ripeness. This step cuts off the water and nutrient supply, forcing the fruit to dry naturally on the vine for up to 40 days. When harvest begins, DOV harvesters move along the rows, applying a light but continuous vibration to release dried berries, which fall onto integrated conveyors and flow directly into onboard bins, creating a closed-loop harvesting system capable of handling 3-4 tons per hour, far beyond any manual process. Despite its advantages, DOV accounts for only about 40% of U.S. raisin production. Many vineyards continue using the traditional method due to the high cost of rebuilding trellis systems and the incompatibility of older orchards with DOV layouts. In the traditional system, grapes are harvested fresh, placed on paper trays between vine rows, and sun-dried for 10 to 20 days. It is labor-intensive and weather-dependent, but dries faster and requires no vineyard redesign. Raisin production brings nearly $1 billion in annual revenue to California, securing the state's position as the world's leading raisin powerhouse. Let's talk about lemons. Did you know that these bright, tangy fruits belong to the species Citrus limon? Lemons have a vibrant yellow peel, a mildly sour taste, and a light, refreshing aroma. In the US, lemons are primarily grown in California, Arizona, and Florida, 3 states with warm climates, plenty of sunshine, and fertile soil, making them perfect for cultivating this citrus fruit. Lemons typically take about 6 to 9 months to grow from blossom to harvest. When summer arrives, you can witness the meticulous harvesting process. Skilled farmers carefully hand-pick each lemon, ensuring that every fruit meets the highest quality standards. It's a delicate and precise task, designed to preserve the freshness and flavor that lemons are known for. Every early morning across the vast lemon orchards in California, when the weather is still cool and refreshing, lemons are carefully picked straight from the branches. Farmers use their hands or simple tools like pruning shears to gently detach the fruit, ensuring the peel remains flawless and undamaged. This process requires meticulous attention to detail, as even the smallest imperfection on the surface can affect the quality and value of the lemon. After being picked, the lemons are carefully placed into soft-lined baskets to prevent bruising or damage. Once the baskets are full, the farmers transfer the lemons into larger containers located at various collection points across the field. These containers are then gathered and prepared for transport to the processing facility. Harvesting lemons entirely by hand not only preserves the natural quality of each fruit, but also reflects the farmer's dedication and meticulous care. From the initial careful handling in the fields to the processing at the factory, every step is taken to ensure that each lemon retains its freshness and signature flavor by the time it reaches the hands of consumers. After the harvest, the containers filled with freshly picked lemons are quickly transported to the collection area at the processing facility. This is where the journey begins, transforming these simple lemons from the fields into high-quality products ready for the market. The process at the facility is carefully designed and highly organized to ensure that each lemon retains its freshness and meets strict food safety standards. First, large containers of lemons are emptied onto an automated conveyor system. Each lemon moves through the initial cleaning steps as the conveyor carries them to the washing system. Here, clean water with just the right amount of pressure removes dirt and soil from the surface of the lemons. In some modern facilities, 360-degree rotating spray nozzles are used to ensure the lemons are thoroughly cleaned from every angle. Next, the lemons pass through a system of fixed drying pads placed along the conveyor. These pads, typically made of soft fabric or rubber, gently touch the surface of the lemons as they move along, removing any remaining water from the washing process. This method not only ensures the lemons are dried quickly, but also helps maintain their natural glossy appearance, preparing them for the next stages of processing. After being cleaned, the lemons are moved to the sorting area, where an automated system with advanced sensors takes over. This system uses cameras and light sensors to assess the size, color, and uniformity of each lemon. The machinery quickly sorts the lemons into different categories, such as large, medium, and small sizes, or separates those meeting export standards from those better suited for domestic markets. This step is crucial as it saves time and reduces errors compared to manual sorting methods. However, skilled workers still play a vital role in overseeing the process, ensuring that any defective lemons or those with minor flaws are not missed during the automated sorting. After being sorted by machines, The lemons that meet quality standards go through a final inspection by skilled workers. They carefully check each lemon to remove any with blemishes, bruises, or other imperfections that fail to meet the required quality standards. The lemons are then moved to the packaging area, where they are arranged into colorful mesh bags or sturdy cardboard boxes, depending on the requirements of each market. These packages are labeled with detailed product information, including the country of origin, weight, and relevant quality standards. In some modern facilities, the entire packaging and labeling process is fully automated, using advanced machinery to maximize speed and precision. This ensures that the lemons are packaged efficiently and consistently before being sent out to markets worldwide. But the journey doesn't end there. Lemons that don't meet the strict quality standards for fresh markets are sent to a dedicated processing area. Here, they are transformed into high-value products like lemon liqueur or lemon juice, ensuring that every lemon serves a purpose. They are then sent to an automatic peeling machine where the peel is carefully removed without damaging the fruit inside. The lemon peel, rich in essential oils and with a distinctive fragrance, is collected separately and sent to the liqueur processing area. After being cleaned and finely chopped, the lemon peel is soaked in containers filled with pure alcohol, usually vodka or food-grade ethanol. This soaking process lasts between 20 and 40 days, allowing the essential oils from the peel to fully infuse into the alcohol. Once the infusion is complete, the mixture is filtered to remove any remaining peel, leaving behind a fragrant lemon-infused liquor. This liquor is then mixed with other ingredients according to a special recipe to create a finished lemon liqueur, such as the famous limoncello. The liqueur is then sent to the bottling area, where automated production lines ensure each bottle is filled with precision and securely sealed. Finally, the lemon liqueur bottles are labeled with detailed product information and packed into boxes, ready for shipment. The liqueur is then sent to the bottling area, where automated production lines ensure each bottle is filled with precision and securely sealed. Finally, the lemon liqueur bottles are labeled with detailed product information and packed into boxes, ready for shipment. But wait, what happens to the fruit pulp after the peel is carefully removed? Of course, it's sent to the juicing area. Here, powerful juicing machines extract every drop of juice from the pulp. The extracted juice is then filtered through a membrane system to remove seeds and pulp residue. This raw juice is pasteurized at low temperatures to preserve its fresh flavor and natural nutrients. The final product is pure lemon juice, which is sent to an automatic bottling line. Each bottle is filled, sealed, and labeled before being packed into large boxes, ready to be transported to the market. Similar to yellow lemons, green lemons, commonly known as Persian limes, are another popular citrus variety. They have smooth, bright green skin, are seedless, and boast a bold, refreshing tartness. This versatile fruit is an essential ingredient in cooking, beverage mixing, and countless recipes worldwide. However, to bring high-quality green lemons to consumers, these fruits must undergo a meticulous journey from the fields to the processing facility. The harvesting of green lemons is done carefully to ensure the highest quality. When the fruit reaches the right level of ripeness, large enough but still maintaining its distinctive green color, farmers begin the picking process. From there, the lemons are quickly transported to the processing facility to begin the next stage of treatment. The process from harvesting to processing at the facility not only ensures quality, but also preserves the fresh, vibrant taste of each lemon.